Hey guys, so now that you have a little bit of experience in predicting whether certain compounds would be water soluble or water insoluble, it sets us up to be able to predict whether or not double replacement reactions would occur. And the reason for this is that whether a reaction occurs or not comes down to solubility. All right, so the rules are going to be if an insoluble product would get formed when you mix two things together. All right, and again, the word for that insoluble product would be a precipitate. A reaction would occur. All right, but if all possible products from when you mix two things together would be soluble, no reaction occurs. All right, so let's apply this to what we did yesterday. All right, so the reactions that we showed in class were, the first one was when we took sodium carbonate, all right, which is a clear solution, all right, and now we should have, understand the reason why it's a clear solution. Anything that starts with sodium would be expected to be water soluble according to the solubility rules, all right, and the other one is a potassium chloride solution, and again, this begins with potassium, and also chlorides are also very soluble. There's actually two reasons that this would be expected to be soluble, and that's why that's a clear solution. All right, so why is it that when we took these two chemicals and mixed them together, we got just a clear solution? All right, we did not see a reaction occur. All right, and it has to do with the possible products that could get formed. Okay, so what I've done is I've just taken these two chemicals right here, and I've written them as their chemical names. All right, and these are both ionic compounds, and so I can identify the positive part, or the positive ion in the ionic compound, and the negative ion. All right, so the sodium would be the positive part, the carbonate would be the negative part. All right, it actually has a -2 charge, but either way, it's still the negative part of this particular compound. All right, potassium is the positive part, chloride is the negative part. So what you first want to do is figure out what the possible products would be if the positive and negative partners were to switch. All right. Okay, and so all I've done here is I've taken the negative thing from this compound right here and I've moved it over here, and I took the negative thing from this compound and I moved it over to here. All right, so the thing is, if you look at these right here and you evaluate these possible products by the solubility rules, we can make a prediction about whether or not they would be soluble. All right, sodium chloride, hopefully you recognize that that would be soluble. All right, but then you also have potassium carbonate, and if you look at your rules for solubility, anything that begins with a group 1 metal is going to be soluble. So this is also soluble. All right, so because all of the products that could get formed are soluble, there is no actual reaction going on. So if you wanted to draw a cartoon representation that would show why we don't get any solid precipitate formed, all right, aqueous sodium carbonate, what you would have is just a bunch of free sodium and carbonate ions swimming around in that solution. That's what you have in this material right here. In the potassium chloride solution, you have just a bunch of free potassium and chloride ions swimming around in the water. And remember, the blue stuff represents water. All right, so notice that the blue, you've got water in between these ions when they're dissolved in water. All right, so when you combine them together, essentially what you have is just a mixture of all of these ions. All right, and you consider all of the possible combinations of a positive ion hooking up with a negative ion, and there are no combinations here that would produce an insoluble product. All right, potassium with chloride is soluble. Potassium with carbonate would be soluble. Sodium with chloride would be soluble. Sodium with carbonate would be soluble. All of those are soluble, and so that's why the thing you get is completely clear. All right, let's contrast that with the thing where we did see a reaction. So in the other reaction, we mixed sodium carbonate solution with calcium nitrate solution. All right, and again, these starting solutions were completely clear. All right, and when we mixed them together, we saw, as we saw yesterday, you get a precipitate get formed. All right, and again, a precipitate is the solid material that forms from a solution. All right, and one thing you'll notice is that if you look at it from the side, it's completely clear at the top, and this has been sitting overnight. And what generally happens with the precipitate is that the material sinks to the bottom. All right, and so if you kind of look at the bottom, you notice you can't see through the bottom of that. It's got a white powder layer at the sitting at the very bottom. All right, so why do we get that material? All right, so what I did was just like I did before. I wrote these compounds as their names, and remember we have a positive thing, a negative thing, a positive thing, and a negative thing. And so when you have these aqueous solutions, you don't have the sodium bonded to the carbonate. They would each individually be swimming around. So what we're going to do is just identify the possible new products that could get formed. All right, so these are the possible products. Now what we need to do is determine whether or not they would be expected to be soluble. All right, so the first one, sodium nitrate. All right, sodium nitrate is, there's two things that would make it soluble. First of all things that begin with sodium are soluble. All things that end in nitrate are soluble. So sodium nitrate is incredibly soluble. All right. The other possible product would be calcium carbonate. And if we take a look at our solubility rules, all right, you'll notice that carbonates, on the side where it says insoluble, it says that all carbonates and phosphates except for group 1 and ammonium are insoluble. So this right here would be predicted to be insoluble. So if you wanted to picture like essentially a cartoon of what would occur when you mix these together, all right, notice that we would have, we have the sodium and the carbonate, all right, which have your sodium ions and the carbonate ions. So those would have these ions right here. Well, what would happen if we mix it together with this material right here, which has got your calcium and your nitrate ions? All right. Well, at the very moment that these two solutions mix, all right, the first thing that you're going to have is just a mixture of all of the ions. All right. But the question then is, what then happens? All right, so if you mix these two solutions that have these ions, what's eventually going to happen is that the ions, all of these ions are eventually going to bump into each other. All right, and so eventually there would be a collision between a calcium ion and a carbonate ion. All right, and when those two things collide, they have a choice to make. Either they would make a soluble compound, in which case they would stay dissolved. They would just bounce off of each other and remain freely swimming independent ions in that solution. But when they come together and they form that temporary ionic bond, if that is an insoluble compound, they would stay stuck to each other, all right, because that's going to be a solid, and when things are insoluble, remember, the ions stay connected to each other. Okay, and so when these calcium ions and these carbonate ions collide, well, what would that make? That would make calcium carbonate. All right, and what we showed is that calcium carbonate is not soluble in water. So when they collide, they make a compound which is going to be a solid material. All right, so that white stuff that you see floating in there is the compound that gets formed from the collision of those ions in the solution when you mix them together. All right, so that's why it appears like that a reaction is occurring, and a reaction is occurring. Okay, so how do we finish up this reaction right here? What we're going to do is we need to turn this into a reaction. So what I've done is I've just brought down the word equation for the reaction that is shown. All right. And again, the nice thing about the word equation is you can just switch the words. You don't need to worry about how many of the ions. You don't have to worry about the formula yet. Go ahead and do that. All right. And notice that in parentheses beside these, I've put either AQ or S, and the S stands for solid. All right. One thing to keep in mind, sometimes people might think that the S stands for soluble. All right, please, remember it stands for solid. All right, and because it's a solid, the solid in that material is not dissolved. All right, what we're going to now do is we're going to turn everything here into formulas. All right, we actually had already started with sodium carbonate as a formula, but the formulas would be. Okay, so to figure out the formula for sodium nitrate, we write down the formulas of the ions. We do the crisscross rule, and we get NaNO3. All right, remember, since it's a 1-to-1 ratio between these, we don't need the parentheses. And that we said was going to be aqueous. All right, when we do the crisscross rule between calcium, which is a +2 ion, with carbonate, which is -2, originally you're going to get this 2-to-2 ratio, but again, that's going to simplify to a 1-to-1 ratio. So calcium CaCO3, and that is a solid. Okay, so the last thing that we need to do is just to balance this. All right, and I'm going to look at these, and I can see that there's 2 nitrate groups over here, but there's only 1 over here. So that means I'm going to need to have a 2 here. But now I've got 2 sodiums on this side, so I need to make sure that everything's balanced over here. Well, I've already got 2 sodiums over here. I've got 1 carbonate here. I've got 1 carbonate over here. I've got 2 calciums over here. All right, sorry, I made a mistake. Calcium nitrate would just be Ca. There should not be a 2 right there. All right, so when I look, I've got 1 calcium over here. I've got 1 calcium over here. I've got 2 nitrates over here. I've got 2 nitrates over here. So this right here would be the final reaction, or this would be the final answer that you would need to demonstrate. All right, so a couple things about it to recognize. Everything, first of all, it shows the formulas correctly, it is balanced correctly, and it also shows the states that these things are in. If a product would be insoluble, you need to put parentheses with an S after it. If it's soluble, put parentheses with AQ, which stands for it's aqueous. It's dissolved in water. Okay, so hopefully that makes sense. I'm going to put some practice problems on my Canvas site for you to practice with that, and we'll discuss this in class tomorrow.